If you guys have any questions, please let me know. Okay. Now, today we will basically start from center of gravity. So, center of gravity is basically defined as a point where all the weight of the object appears to act. Now, so remember that here writing this word appears is very important because it is a keyword here, and I just want to write a note here, and the note is that this point can be outside the body as well. Alright, so you guys need to remember that. Then you got center of mass, and center of mass is basically defined as a point where all the mass of an object seems to be concentrated. Especially it's important in A2 that you guys need to remember. All right. So usually near the Earth's surface, because near the Earth's surface you guys need to remember that both center of mass and center of gravity stay the same, because near the Earth's surface it feels like that it is flat and the field is constant. So you have constant gravitational field strength. Near Earth's surface. However, if you look at the Earth from a distance, you realize that these lines, this field is not constant. It's basically a radial field. So far away from Earth's surface, center of mass remains same, but center of gravity may change. Alright, is it clear, everybody? Aman, Hamad, Ramin, Javeria, Aisha, everybody's clear, right? Right. I don't know what I did here. Okay. Anyway, I was trying to make this clear, so I just wanted to tell you, if you really want to locate the center of gravity on a regular shape, it's pretty easy. So they could be like a square, and then it could be a rectangle, it could be a triangle, or it could be a circle. Any of these shapes, you just need to draw line of symmetries. What line of symmetry is? Line of symmetry is a line that equally, halves this off. So where the line of symmetry coincides, that would be where the weight will be acting, and that's your center of gravity. Same goes for a rectangle, so you can easily find the center of gravity. Same goes for a triangle. You can actually go through all vertices. Where it meets, usually this is the point where the center of gravity lies. And for a circle, it is where the two diameters meet. That's centers for these uniform shapes. For irregular shapes, we don't there is a method to find it. I mean, you know that you could use the lamina, but it's not really required. Just let me tell you why that happens, and then we're gonna go forward. So usually for an irregular shape, what you guys gonna do is that so lamina, let's suppose we're finding you might have learned this in O levels already. Basically, you can hang the card loosely at one end. That would cause the card to be that you can freely move. And when you apply a force on it, basically this is where the pivot is, and this is the line of action of that. So the weight of this, which is basically somewhere where the center of gravity is, I don't know, maybe it's here. So the weight from there is acting downwards, and because there is a perpendicular distance till the pivot, that's why it will rotate back anti-clockwise as soon as you leave this. What I mean by this is, just copy this. I did not need to make two of these. So something like it would actually come back to here like this. Rotate back to the normal equilibrium point, right? So you guys need to remember that it is basically, as soon as this force is removed, the weight of this from the center of gravity lets it align with the pivot. You can make three different sections or lines, and then wherever it intersects, that's how we do it. But we don't really need to know it, we just need to know why it basically turns like this. Okay, all right. Now the point is that we're doing this center of gravity thing right now, but the point is why do we need center of gravity? Okay, and what is the point of center of gravity? So first of all, I'll give you an example and then I'll explain it to you why it is so important. For example, and I'll ask you guys to do it first, so be ready. So suppose there is an object right here. In fact, let me make it a bit differently. It's basically like this. It is 4 meters from here and it is 2 meters from here. Alright. They have given this distance, the height of the shelf or whatever it is, as 3 meters. And then it says it falls down. When it falls down, it falls onto the other face. So naturally, now this distance is 4 meters and this is 2 meters. Okay. Now they say a uniform density rectangular block falls from a height of 3 meters onto the floor. On the other face as shown. Now it says what is the height Alright. So first question is, what is the height of center of gravity after falling? And part 2, it says calculate the loss of gravitational potential energy if the weight of block is 500 newtons. Do you guys understand the question? Okay. All right. So I just want you to look at this question and try if you can do it, please. If you don't remember, the formula for gravitational potential energy is mass times gravity times height. guys done? Please give me an answer, please. Yes, Hamad. What did you get for the first one?
मैंने पास क्लास मिस की थी तो मुझे समझ नहीं आई.
But I just taught you center of gravity, beta.
Yeah, but इसमें इतना ये क्वेश्चन समझ नहीं आया मुझे इतना.
Okay. Aman, what about you?
Sir, give me 1 more minute.
Okay. Hamad, you really need to review the lectures. I post every lecture every day. You know this?
किधर?
Are you in Google Classroom? No?
No.
Oh my god. Okay. When the class ends, I'm going to put you in Google Classroom. All the lectures are there. You can review them, okay? And I mean, we are also starting the catch-up class on Sunday. From Sunday, you can join that too. Okay?
What time?
I think it would be best if we keep it somewhere around 7 o'clock. Okay? Okay. Ramin, Aisha, Javeria, please give me an answer. Don't be please.
Just 1 second.
Oh, okay. Ramin, are you there?
Yes, sir.
Okay, Ramin. Ramin, you know what you do?
No.
Okay, I'll tell you. You basically raised my heart rate to very, very high
Why?
because of your guest appearances in this class. Like, oh my god, look at Ramin is here. I'm like this. Huh?
I try my best, but something comes up every time.
Okay. Alright. Now, Ramin, at least you have done this. You could tell me.
But I want you to tell me first.
Okay. First one is
Yeah,
1. That is correct. Okay.
Is it 1?
Yeah. Why is it 1? Because
I thought it's wrong because it's so easy and no one was answering, so I didn't say anything. I thought there's more working to it.
why do you think A level is that hard? Now, the reason is that center of gravity, you just need to make two. Hamad, you need to make two line symmetries, right? So that would be here. So from this point, this is the weight what we're looking for. So it means that this point is, if you look at it, it's just 1 meter high. And if I want to find the center of gravity old one, if they had said that, so now it would be from the bottom, it would be 2 meters. Do you understand?
Yeah.
Okay. Now next, please. Okay, Ramin, give me your easy answer for the next one.
1500, that's an easy answer.
1500, okay.
I know there's more to that for sure.
Okay, fine. And Aisha and Aman and Javeria, what do you guys say about this one?
Sir, I think it's 1500 too.
Okay. Aman? Please
So
prove them
same
wrong.
1500.
Oh, wow. Everybody's in accord on this. Okay, yeah. And Javeria, do you think it's 1500 too?
Yeah, I think there's some more working, but
Okay. So you don't think it should be that easy, right? Well, you guys are correct because the answer you're telling is wrong. So basically, the reason I put this question is to clear your concept about center of gravity. Okay, usually in O levels they did not teach you wrong. They just did not give you like a question that would change its shape, right? They would just give you one particular, like a square or a circle, so it doesn't really matter. The thing is that basically the weight is truly acting from this point, right? Which is 2 meters above this. And when it falls, it basically falls to this point, which is now 1 meter above the surface. So if I, check this out. From the surface, I'll just make an arrow. From the surface, this distance is not actually, the center of gravity is not at 3, it's actually at 5 meters. Do you guys understand this, what I'm saying? And then from the same reference of the surface, we can say, okay, this distance is just 1 meter. We just realized that's why he asked this. Okay. So the difference.
Sir, how did you get 5?
You check from the bottom, from here, 3 and 2 is the center of gravity above it. Do you understand?
So 5 is the center of gravity of the large one?
When it was placed at the top, the center of gravity where the weight was acting was 5. Do you understand?
Yes.
And when it fell on the other face, now the center of gravity from the same reference, which is the bottom, it is just 1. Do you understand? This means that actually the change in height was 4 meters, not 3. So the correct way to do this is that you write basically 5,500 newtons times 4. So this will be 2000 joules is the loss of gravitational potential energy. The wrong way is that you completely ignore the position of center of gravity and you simply do what you did in O levels, and that was 500 weight times the height, that is 3, so it would be 1500. Do you guys understand what I just wanted to clear this point. I knew you'd do it wrong. Okay. Because everybody from O levels, when they come into A levels, they're like, because they've never done anything like this, because they don't know, okay, the center of gravity might also, change. I mean, position might be changed because of the face. But now you know that you always take the height from the ground to the center of the object where the center of gravity is. Do you guys understand now? Any questions?
Sir, so we have to take the same height as it was before falling?
But you won't start the height from, basically what you guys have done is you've taken the height till here. That's how it becomes 3, right? But that's not true, because the height is still here, which is 5. You add 2 to, is it clear? Like that. So
Sir, I don't get that.
what I'm saying is, the 3 represents the height from this point to this point. That is not the center of gravity, don't you think so?
Yes.
The center of gravity is here. So the height at which its weight is acting is from this to this. That's why we took 5. Understood?
Yeah, but then why are we multiplying 500 with 4?
Oh my god. The formula is mgh. What is mg? Weight times height
500.
times 4. Oh, you're saying why is 4 there? That's what you're saying? Oh, okay.
Yeah.
Now when it falls, the weight is right here. What is the height? 1 meters, right? So it says what is the change in gravitational potential energy? How much loss there is? So from this point to this point, what is the height then? Total was 5 minus 1 is 4. Ramin, so it has fallen. So you look at from the
Yeah.
center of gravity to center of gravity. Understood?
Yes.
Okay. Alright, Javeria, is it clear? Aisha, Aman, Hamad.
Yes, sir.
Okay.
Yes, sir.
Now the next question that I want to discuss with you, because this is entirely a brand new concept as well, and please stay with me on this. Basically, the question is about, first, instead of writing example, let me tell you about the toppling point. So toppling point is basically, you guys need to remember that if you place an object which is much stable like this, okay, and it is like face A, that's B, that's C and D, and the center of gravity is right at the center where the weight is acting, right? Now what you do is you apply a force on this, and when you apply the force, the object might, so you're applying a force like this. So this was A, this was B, this was C, this was D. The moment the center of gravity, which was here, is basically the line of action where the weight is acting, is exactly at this point where it is between B and C. This is called the toppling point, because even if you just push it like just enough, you don't do anything after that, what really happens is that this object is gonna fall like this. Do you guys agree? So to topple anything, you just need to bring it to this point, and if at this point a little bit of more force is applied, it will automatically fall down. You don't need to do anything. So the minimum work you do is that the work done to bring it in this particular point. Do you guys understand this?
Yeah.
So basically, if the weight direction where the center of gravity weight is acting, if it changes the dimension where it is, like it was at A, now it has shifted to B a little bit, then it will just continue to topple. Now, because of this, I just want to do a little bit this work done to bring an object to the toppling point. So I just wanted to show you this. Okay, it has to do with center of gravity actually. So we'll take the example of the same mass that we discussed earlier. Is that okay? This is 2 meters. And this is 4 meters. And suppose they say, okay, it is at the center, and the weight is 500 Newton. So this is the same object we discussed earlier. This is 2 meters. Now, if I just need to find the work done just to bring something to toppling point, so I know that I need to bring this mass to a point like this, right? Where the weight is going to act just here, right there. So this is 2 meters and this is 4 meters. Everybody agree to this? Okay. Now, currently, if I ask you what is the height of the center of gravity, what are you going to tell me? What is the height center of gravity when it was like here.
2 meters.
So from the bottom, you just need to go half of this. So this is going to be 2 meters, right? Now, if I extend this line, you might realize that this makes it a right angle triangle, right? With this side is 2 meters and that is 4. Oh no. Okay, sorry. So, where was I? Yeah. I forgot to tell you that you need to rejoin. I'm sorry about that. Okay. So, now, check this out. So the moment it's like this, so this is 2, that's 90 degrees. If I want to find basically this height, right, where are the shapes gone? Oh, that's it. If I want to find this height, right, so I need to take Pythagoras theorem, right? So what I can do is I can say
4.47.
yeah, so it will be 4 square plus 2 square root, and this will be 4.472 meters. Is that right, Rami? Okay. Now,
Yes, sir.
because I know center of gravity is in the center, so it means that this object, if I want to find this height from the bottom, this would be y divided by 2. So that's going to be 4.4 divided by 2. So basically I'm finding h. And that's going to be exactly 2.24 meters. Is it clear, Hamad?
Yes.
Okay. So now we have the new height. Now check this out. Check the magic, right? To topple it, before toppling, the height was 2. And now to topple this, when we applied a force, the height has changed to 2.24. Alright, so basically by applying the force, we have raised the center of gravity by this much. So the change in height of the center of gravity would be 2.24 meters minus 2.0 meters. So that's going to be equal to 0.24 meter is the change that this force has caused, right? And this change is against the weight. So the work done, which is basically force times displacement. The force was the 500 Newton and the displacement was 0.24. That basically makes it 120 joules of work is need to be done against the gravity to bring it to the toppling point. Do you guys understand this? So remember, do not take it as just another O-level concept. Okay, O-levels, we did not really care about center of gravity, but now we will care about center of gravity. Every energy question or say moment question, you guys need to remember that it will depend on center of gravity somehow or another. So you always have to keep this in mind. Is it clear, everybody?
Yes, sir.
Right, very good. Now, so I just want to, keep this still here because I don't want you to feel overwhelmed by it. Tonight or tomorrow, just go through the recording once more, okay? And see where you do not understand something and let me know tomorrow so I can explain it to you in a different way then. Alright?